Today we're going to begin 11.2 on right angle triangle trigonometry. So this should be review for everyone, whether you are now Algebra 2 or pre-calculus. So I'm going to break this up into 2 days or 2 class periods, even though I probably could power through. I'm going to make it a little bit shorter for you. So the big idea here is in the objective, students will be able to use SOHCAHTOA in order to solve a right triangle. That's what we're going to accomplish today. We're going to use the Greek letter Q for the angle, SOHCAHTOA. So let me draw a picture here. If I put this is angle Q, okay, this is angle Q, then this is the opposite of Q, this is the adjacent to Q, and the hypotenuse is always across from the right angle. So the opposite adjacent can flip depending on which side or which angle you're coming from. One thing I want to talk about, it's not really dealt with in this section, but we are going to use it in the next chapter, is the two special right triangles. If you have a 45-45 right triangle, then the legs are 1, 1, and the hypotenuse is square root 2. In a 30-60, across from the 30 is 1, the hypotenuse is double, and across from 60 is radical 3. So what's really quite nice is sine of 30 is 1/2, sine of 45 is radical 2/2, and sine of 60 is radical 3/2. So I'm doing opposite, okay, opposite over hypotenuse. So from SOHCAHTOA. Likewise, cosine 30 is radical 3/2. Cosine 45 is radical 2/2. And cosine 60 is 1/2. Tangent theta is 1 over radical 3, which simplifies to radical 3/3. Tangent 45 is 1/1. And tangent 60 is radical 3/1. Please be memorizing these if you don't remember them. You can take your time, but you really need to have almost a knee-jerk reaction to, if I said, what's sine 60? Immediately be able to say radical 3/2. You can make a Quizlet, you can make index cards, anything, and just start practicing them 3 or 4 days a week. Okay, so let's look at this example 3 from the textbook. Number 1 says find the value of theta. So I have, from theta, I have the adjacent and the hypotenuse. So which trig function would I use if I know the adjacent and the hypotenuse? Well, you should use cosine. So we're going to say cosine theta equals 4/8. Well, cosine theta is 1/2. So look at your table. So don't touch a calculator, okay? Don't touch a calculator here. The cosine of theta that gives you 1/2 is theta is 60 degrees. Number 2. Let's look at the what you're given here. So I have the angle, I have the opposite, and x is the hypotenuse. So which trig function out of sine, cosine, tangent is opposite over hypotenuse? Well, that would be the sine function. So you're going to write sine 30 degrees equals 10.8 over x. Well, looking at the chart, or hopefully you know it, what is the sine of 30 degrees? Well, the sine of 30 degrees is 1/2. So what you're going to do is you are going to cross multiply and get x equals 21.6. All right, in example 4, number 1, it says find k. Well, here's k. And I have opposite and adjacent. What trig function would be opposite and adjacent? Well, that is tangent. So you're going to say tangent of k equals 4/3. All right, now there is no 4 over 3 in the chart above. So when it's not 1/2, radical 2 over 2, radical 3 over 2, radical 3, 1, or radical 3 over 3, then you are going to use your calculator. So you're going to do inverse tangent 4 over 3. There's a button on the calculator. All right, so tell me, what do you get? And make sure you're in degree mode. I got 53.1 degrees. All right, number 2. Find the value of r. So I've got an angle here, and I have opposite and hypotenuse. What trig function is that? Opposite over hypotenuse. That's the sine function. So I'm going to write the sine of 38 degrees is opposite over hypotenuse. Go ahead then and calculate the sine of 38 degrees. All right, what did you get? I got 0.616 equals 21 over r. Then just cross multiply. And what do you get for r? Again, making sure you're in degree mode, I got 31.4, or that's not degrees, sorry. Just kidding, that's the side length, 34.1. Just kidding. All right, that's as far as I wanted to do today. So do a nice small chunk.